In the last video, we had a look at analyzing this shader, the shader that gives rise to this picture. And I thought that in this video, we'll try to create something like this ourselves, but of course, we'll probably be heavily inspired by what we have here. So let's actually go ahead and open an editor and let's do Kaggle run release. Let's make a new project that will say, let's just say from scratch. So we have it here. And now let's find the shader file, and here we go. Now we are ready. So I think I would like something. So let's go ahead and say the 2p is right by 2. So what this will do is rescale it so it's from 0 to 1, 0 on the left, 1 on the right, 0 on the bottom, and 1 on the top, I think. So one way we can test that is we can just say position x and 1. And it looks like, sorry, not position, but p. And yeah, so that looks more correct. We do y, it's gonna go from the bottom to the top. It's black in the bottom, that means it's 0. How does this look? Probably just look back at the mango. All right, so far so good. So now I would like some kind of function that we can use to build other things that's localized at a certain spot. And we can use, for example, a Gaussian. So maybe we'll have it looking like this. It takes a position, it takes a location, and it takes a standard deviation, a variance. We can call it, let's just call it variance. And what we want to return is something like the exponential of, let's see, we want something like, well, result, p minus location, times p minus location, divided by the variance. And then we want minus result x minus result y, like that. And then here, let's say we call it f or whatever. So we take the Gaussian, we feed in the position, then we need a location. What location should we take? We could take in the middle of the screen, or which in this case would be 0.5, 0.5. And the variance, let's try to say 0.2, 1.2. And if we plot that in the red channel, we should see something that's a bit localized. We should make this even smaller again. All right. I think I'm gonna change this so it's actually not the variance, it's actually the standard deviation. I think it's a little bit better. Now if we put a standard deviation of 1, it's kind of filling the whole thing. And now it's more or less 10% of the image. If we change them so they're different values, you can see we get this elongated thing. So I think this is useful. All right, let's have a look at this other shader, which we analyzed last time. And it had this interesting function, this one. And maybe we can even try to plot that again. And we need an L. What was L? L is this weird thing. So we can get that. And it looks totally wrong. Plot the x, we can try to plot the x, so vx minus vx. And then it's not 0. Another thing we should probably do is to have this scale parameter, so we can kind of shift things around and scale it. So I'm going to do like this, and then I will say p is equal to px minus rx, or rather, let's say it's p minus rxy divided by z. And it shouldn't do anything, but if we this stuff isn't really working, so let's get rid of that. Go back to this thing. We can scale things a little bit, not too much. Why does it go up there? I'm not sure. Shouldn't divide by 0. For some reason. Maybe we should say 2. And then 2 like that. Okay, and if I do 2, that looks a little bit more like I wanted it to do. And I can shift it by a little bit, shifts up and so on. So that's a nice thing to have. All right. Let's try to create some kind of interesting function. We can be inspired by this, where it has some signs and some stuff. There's also an L, which is kind of like squared something. So let's try to create something. Okay. I'm gonna call it V as well. We're gonna take something like, let's try this pattern again. We can take the position and maybe multiply by f time, just f. And let's see what we get out of that. And that's right, we need something here that's not. Let's do that. So that didn't really do much. What if we do this? Maybe we do this one again. Oh, I'll put it in the blue channel because it looks a little bit better. Didn't change anything. And here maybe we'll plus. Now it's very red. We can localize it. And okay, this one, if we make a change faster, and actually I think I want something like that. Okay, maybe we make this wider. All right, maybe that was a bit too wide, I think. Okay, maybe this is something. So we can have another V as well. Maybe we'll just call it V for now. And we can say Y instead. It should look like that. And this one, maybe we don't do as much. And it never becomes negative. So this one did actually become negative, I think. So what if we put a 0 here and maybe like scale it up overall? Okay, so now we kind of have something interesting. Let's combine them. So it would look like this. P minus 1/2 times vec2 40 20 times f vec2 1 2. Okay, there we go. It's not going to compile now. Of course, because of this thing. So let's try with the x. And I'm missing some kind of parenthesis here. And here again. All right, so it looks like that. And if we change it to y, it looks like that. All right. So now let's try to decide what the color should be. And this one had this interesting py, it's y dependence. But what if we say, so we want like a color weighting, I think, color weight. And it's gonna be, what did we do here? It had some kind of dependence on x as well. But for now, maybe let's do it like this. And then this could be maybe just 1. And we do like color weight like that. And this then has to be turned into a vector for. That. And it was not really. All right. Great. It's completely white. So don't understand. So we have ones, and then they should be kind of dragged down. It's because we have a minus here. Let's not do a minus, so we do like that. Okay. Now we can change these values. Like if we put an 8 here, it becomes this weird color. Okay, so we have that. Let's try to add some, do like this. And what did we do here? There was some overall weighting. Okay. I don't really know what I'm doing, so I hope you don't mind. If we multiply by the f, it should be kind of localized. And still, I wanted to go to black, which is unfortunately not what it's doing. How did we achieve that here? Maybe I should put this out here. That should make it go to black. And what if we take the color weight and multiply by like this? We do get some different colors. I can kind of play around with it. right. Let's try this kind of thing where we're adding a lot of complexity. So this I don't mind, we can keep that. We need an O. So let's say O, 3, 0. And we don't have a T, we don't have a time, so let's get rid of that. And right, it should be a vector 4. Okay. And now we can divide by O like before. But the V also changes. So maybe what if we get rid of that here? Maybe we get rid of that for now. Okay. Actually, maybe we had a T here, right? So let's add the T back in. And let's say it's a uniform float. Let's call it time, or let's call it T, whatever. And then we can go over here, we can add T. Just do like that. And see what happens. Oh, now that's kind of interesting. So like around 42. There's definitely some interesting patterns in here. Let's go with the 42 one. It would be really interesting to see this evolve in time. Maybe I don't like that so much anyway. It was 37, 39. Was it 60 something? It's kind of the same. It's 42. It's also very sensitive. Seems like if I just change it a little bit, it changes a lot. So let's go with this 42.7. I'm gonna record that here, even though it's probably not. It's probably gonna change a lot when we change other things. So even these colors are like kind of okay. They're kind of okay. What happens if we put F in here again? It's also, I mean, it's kind of interesting, honestly. So, but whatever. Put the F back in. Kind of interesting. What if we do 2 Fs? It's probably too much. Let's do 1 F here and another F here. Nah, okay. Let's just keep it like that. And what if we change the color things a little bit? What if it's equal? That's not so good. Okay. What can we change more? What if we had some more details here, like a lot. And I think there was something we agreed, like this one should be, if we increase the number of iterations, we also need to change that. And it looks completely crazy. Oh, get it to look very bright. That's cool. It's very cool. And now we have to change it back, I guess. So we get that one. 8 was actually kind of okay. What if we do 100? Has many details, and we can increase this one a little bit. No, we need to make it even smaller. And now it's too bright, so we need to make it larger. Overall, it's probably too much with, at least for these kind of values that we have. So let's just stick with 10. It's a nice number. And we'll change this one to 0.7, 0.2, 0.15, 0.15. Good. All right, but it looks like this expression is kind of doing all of the interesting stuff. What if I change it to 20, 20 and 20? So you can kind of change the shape here. And that's probably something you want to experiment with a little bit. So let's do uniform float, and we'll call it kx. We'll do another one that we call ky, and we are putting that. I'm also gonna just kind of save that, and then here we'll do kx, ky. Now they are 0. Oh, incidentally, also kind of interesting. Kx. Let's do the maximum range, and ky maximum range, and let's try something like that. So of course, if we make it like larger in absolute value, it will get like more and more of these oscillations. Now we can try to change that one as well. Let's go back to 42 something. 2.7 was for some reason the only value that works. All right. So, but the interesting thing with this thing was it had these little tendrils coming out. So maybe we need to change how we do f even more. Oh, sorry, how we do the v. Maybe this one. This term, does it do anything? What if we do plus? Nothing. What if we do times? No. It's not really. How about this one? If we do xy, xy. So before xy, yx, or yx, xy maybe. It's kind of good. Doesn't really change anything. It's too similar. Okay, this is kind of good. What if we make it overall more red? More blue, more blue. Somehow this is a good combination, I feel like. So let's stick to that for now. I think probably we want the, like, didn't we have that? We had something up here like times L. So we want that. Can we make our own L? What if we do this? No. So this is too. Let's do it twice, just for fun. $500. Why is it doing this? So that means we're getting close to 0, which means that this is kind of like a way too large number. So what if we divide it by some large number? Like, is it actually doing anything interesting? I don't think so. I think we need another function to help us. So let's call it L, and let's make it, Let's call it L. And what will it be? Maybe we'll just do P minus 1/2. P minus 1/2. If we take the absolute value of that and we say minus 0.25, and this thing, we have a power function. I'm able to find function, there's no power function. There actually is a power function, but it just doesn't. Maybe I have to do like that. Okay, so that works. And how does this actually look? So out color, vec 2, sorry, vec 4 actually equals vec 4. It's hard to see anything. So it looks like that. So maybe I want to scale this down. Maybe not. Actually, I didn't think it would look like this. Let me think about this. Because we agree that P of x is like that. P of x minus 1/2 is like that. Then do this. That means the absolute value of that minus 0.25 is if I do that, looks like this. And maybe I don't know what to say. Let's go with this function and maybe don't use such a high power. Let's use some K. Okay. What if we also like maybe not 10 now? It's 5. And we subtract something. Holy shit. Why is there a region of 0? I don't get that. Okay, let's try something else. Let's try to make a ring function. It takes the position, takes the location of the ring, and it takes the radius. Now, how would that look? We want it to be, actually, we also need the width of the ring. So we want it to be when when like p is equal to location plus radius, it should be 1. And then when p is equal to location plus radius plus width, it should kind of be equal to 0. So how can we do that? Maybe we do another exponential function and we say, first of all, what's the distance to the center of the ring? Okay, it's this. Then we can say distance times distance divided by 2 times maybe, wait, it's not really going to be correct. Okay, and then if we do this function instead of this random crap, we actually do a ring, but it just returns a float now. Is this okay? So we do a ring with p. Where is the location? Let's put it in the center for now, as above. The radius can be 0.2. The width can be. Let us see how that looks. And there's no x, of course, anymore because it's not fx anymore. So that is wrong. Right, because it's not this, it's not minus the location. We actually need like dist prime is gonna be it's gonna be dist minus the radius, and then it's gonna be that one we're using here. And I think that's okay. Now we want this one to be e. Oh. Is this correct? I think it's correct. Yeah. We need to do it twice though, I think. Yeah, there we go. Okay, now we have the ring. Now we have a nice ring. This guy, we can kind of move it. For example, actually, what just for fun, what happens if we put a p here? It's probably gonna not make it. Yeah, it doesn't make any sense. But we could try to use the v for that. V. Right. Good. Let's add a little bit. Okay. And can we now do something like this with L as well? So let's do a cosine of L. Whatever. And this thing I don't really need. I plus 0.1. Why not like that? That was not a good idea. This is too large, I suppose. It doesn't really do anything interesting. What if we use V again? Oh, now we're talking. Now we are talking. And we can even say like if if this is 0, then we do that. Otherwise, we do this with a y, and then we say it's. And this one could even be smaller, I think. Okay. What if we have like this. Yeah, okay. We need something with L in here, so let's add the L. That's not good. Maybe plus L. So here instead. So it's almost like this doesn't really matter, because if I do this, it doesn't change a lot. So we're doing something wrong for sure. Doing something wrong. Let's get rid of this. And let's go ahead and say, oh, yeah. So what did that do? It just smooths it all out. Why is that? So if we don't do that, we have the ring located over there. Maybe we can even say minus this, and with like some different values. Okay, can I do that? It goes over there, 2. Let's make it wider. We can make it very narrow like that. That's cool. Try that one. Still does that. Maybe this plus here is not a good thing. It's not that. Somehow doing this is messing it up. Maybe, or maybe this part is quite important. Like plus I as well. No. No. Okay, what if we don't use that too much? Interesting. What if we do a vector 2? And this is the first component. And the second component is something very similar, except we move it a bit. Let's get rid of that. Let's first verify how that the x hasn't changed so much. And then let's look at the y. It looks like that. I kind of want to move it somewhere else. So that's not good. And what if we do something like this? Is that interesting? Not really. Okay, let's not do that, but maybe we can flip this. No, that doesn't really change anything, I guess. Okay, so we have that. Want to make it smaller, maybe larger instead. That's kind of interesting, like that. And the blue part can also get it kind of over there. Do that. Okay, this is good. And then here I'm gonna try to do this same thing where we kind of like swap the components. Let's see how that looks. It's not horrible. It's not horrible. Like that. It is a little bit annoying that you kind of get value everywhere, and it's not this one. It's not that one. What if we just like decrease it a little bit, get it closer to 0? Okay. So we have that. What can we do with this weird function that we made? Maybe we can multiply it here. It's not gonna work because it has to be a vector 3. So maybe we just like do LX6. Why not? Okay. This is because we get things that are close to 0 when we do that. Right, so if I multiply by 20, sorry, that's not it. Not it. No, this is still gonna do that same thing. So, what? Okay, sorry about that. Let's get rid of this. Let's try it here. So LX, why not? It's kind of weird. So yeah, I don't think it shouldn't be here. That's not right. But it could be in the weights. But how did we do it here? It's just LX, and it's actually a separate function. And here we also have hyperbolic tangent. That's interesting. Let's try the hyperbolic tangent because that will kind of cap everything. Maybe, I don't know. So let's try that. Lx, yx. And we should multiply. We just get these. It's not too interesting. So let's maybe put it here. Actually, why don't I just put it here? It makes it a little bit easier. So Lxyx. But if we don't do that, this is so weird. So really in this shader we have the only thing that's changing the colors is the O, and then we have some terms that change the intensity of the color. So maybe let's go with that same approach. So we have this, and now let's try to change just the intensity, and it could be this. For example, okay, so that's a little bit too much. What if we do an exponential? It's not super impressive, say. So is that actually a small improvement? Yeah, I think so. It adds a little bit, right? It adds a little bit of detail. Kind of flat in some areas now. A little bit of detail. So I think that's good. That's pretty good. This shape, though, this shape, can we make it more interesting? So can we run this, but for multiple positions? So I kind of want to do something like, what if we do this? 0.3, get like another blob over there. Let's make it actually smaller. Maybe that's too small. How about that? Even like this could be interesting. And then maybe we move this one a little bit to the side and a little bit up. What if we just make this one very large? Kind of see that a little bit of boring shape. I think this would be more interesting if we animated it. Some interesting things here. So it's changing a little bit too fast. I think we have to do that. Good stuff. 3. Doesn't really matter. We have a sine there, cosine. That's, nope. Nope. Has to be the cosine. What if we only do the hyperbolic tangent on 1, for example, the y? Didn't really change anything, but maybe it's because we do this kind of swapping here. What if we do x things? Yeah. Keep it like that. Maybe what if we do this one? Hyperbolic sine. Holy moly. Is there something interesting here? I don't know. Let's try the time. We should implement something so if you press enter, it will automatically apply things. So apply or add from open A. Okay, we can press A. I forgot I implemented that. So with the shader here, I can do something like this. this is fairly interesting. I think I'm going to stop here because it's already quite a long video. Let's snap a screenshot and I will see you in the next one. Bye bye.